everyone, and welcome to today's lecture. My name is Jun, and I'm a third year student at NCKU, majoring in resource engineering. This course is deeply connected to our department's mission of promoting sustainability and innovative engineering solutions. We will explore the fascinating journey from raw materials to valuable resource. You will discover how we can turn garbage to gold through advanced recycling method and creative problem solving. Thank you for joining me, and I hope you enjoy the class. To begin, let's define what resource recycling is all about. In mineral processing, the process can be divided into four main stages: comminution, sizing, concentration, and watering. To put it simply, imagine you are a miner looking something valuable where you want. First, you need to break large rocks into the smaller one, ensuring that the particles are evenly reduced. Next, you apply specialized machine and techniques to suppress the minerals. It is extremely important to distinguish between valuable minerals, such as gold and the unwanted materials during the whole recycling process. In following class, we will dive deeply and explore the critical roles they play in mineral recycling. In this chapter, I would like to talk about comminution. Imagine that some child arrives at a facility which load with massive amount of raw ore. These materials are bulky, uneven, and filled with both valuable minerals and waste. To find out what truly matters, we need to break these large rocks into smaller ones, more manageable. These processes we usually call comminution. Comminution is the process of reducing the size of solid. It is like breaking down a giant puzzle into smaller. Through crushing and grinding, we can ensure that valuable minerals are liberated and separated from the waste. Let's look at the particle size distribution curve. If the base of pyramid is too wide, it means our comminution process hasn't performed well. Large particles remain unbroken, and valuable minerals may still be trapped within. On the other hand, a narrow base with more evenly distributed particle size indicates better comminution efficiency. Overall, concentrating narrows the base and increases the area of useful materials. Comminution is about precision and efficiency way. By refining this process, we save time, save energy, and resource, while maximizing the recovery of valuable materials from every load of ore. Screening is a crucial step in our mineral processing. After comminution, the ore particle we get are often of varying size, making it inefficient to process them all together. By screening the minerals, we can ensure that similar sized particles are treated in the same way. Let me show you an intuitive example. When we place ores in a fluid, heavier particles will usually sink faster, while lighter ones stay higher. By using this difference, we can separate the materials more accurately. Gravity classification helps us force not just by size, but by their extra characteristics, making the separation process much better. Both methods we mentioned allow us to get more useful mirrors as well as save time and resource. These methods take advantage of the hydrophobic and hydrophilic properties of mirrors. First, we mix the ore with water to form a slurry from extraction. Then we add specific chemical making the valuable mirrors hydrophobic. At the same time, air bubbles are introduced into the slurry. The hydrophobic mirrors stick to these bubbles and rise to the surface. The waste material remains hydrophilic and sink to the bottom. The combination of bubble and hydrophobic properties allow us to effectively separate mirrors based on their behavior in water. Flotation is like using bubble as carriers, selectively lifting the valuable material out of the slurry. It is an effective way to recover even the smallest particles of valuable mirrors. In this chapter, I would like to share about two important methods for separating mirrors: magnetic separation and electric separation. First, let's start with electric separation. This method works by giving mirrors an electric charge through different ways, such as rubbing, touching, or induction. Once mirror charge, mirror lights conduct electricity like some metals can be separated from non-conductive materials like quartz or other rocks. The other method is magnetic separation. It uses a magnetic field to pull out material that are attracted to magnets, such as magnets. On the other hand, materials that are not magnetic won't be affected by the magnetic field. By adjusting the strength of the magnetic field, we can suppress magnetic material furtherly together. These two methods provide simple and effective ways to suppress mirror. They are widely used in mining to reduce waste and make sure we recover as much as valuable material as possible. In this chapter, I'm going to talk about sensor-based sorting. This method uses advanced sensors to suppress materials based on their specific physical properties, and it is now widely used in different recycling industries. Sensor-based sorting was by using various sensors, including optical, infrared, and X-ray system, to detect materials based on their characteristics. For example, color sensors can identify materials by their color, while transparency sensors can detect how much light passes through an object. Reflective index sensors help differentiate materials based on how they bend the light. Infrared sensors can identify specific chemical compositions based on how material absorb or reflect infrared light. On top of this, sensors can also measure size and shape, allowing them to source materials more accurately. Sensor-based sorting can quickly and accurately identify and source materials based on multiple properties. They make the separation process much faster than traditional methods. In this chapter, I'm going to connect theoretical concept to real-world application. I'm going to using solar panel recycling as an example. The process begins with commission, where solar panels are broken into smaller pieces, separating materials like glass, metals, and polymers to access valuable components. Next is sizing, which through the crushed material by size. Smaller gas fragments are separated from larger components, such as aluminum frames. Then using magnetic and electrostatic separation. These methods create an efficient solar panel recycling system, enabling the recovery of critical resources like silicon, aluminum, and rare metal. This reduces environmental impact and supports a circular economy. In conclusion, by applying methods like commission, sizing, concentration, and sensor specialty, we elevate sustainability and resource management. Thank you for listening. I hope you have gained new insights and learned a lot from today's Bridget clip and Bridget class. In the final, I'm truly grateful for the opportunity to be your speaker in this class, and I wish you all the best in achieving outstanding academic success in the future.